Hello everyone, myself Bhanu Prakash Chintam from Data Structures and Algorithm class. Today I'm going to talk about the Rabin-Karp algorithm, a really cool and efficient way to search for patterns in a big chunk of text. Imagine trying to find a specific sentence in a long book or detecting plagiarism in research papers. So doing it the slow way, checking every letter one by one is exhausting, right? So that's where this algorithm comes in. It uses hashing to speed things up. Over the next 5 minutes, I'll break down how it works, where it's used, and why it's so effective. So coming to next slide, presentation outline. So all right, here's what I am going to cover today. First, I'll explain what problems this algorithm solves. Then we'll look at some real world application things like plagiarism detection and cybersecurity. Next, I'll walk you through how it works step by step and show an example so you can actually see it in action. We'll also talk about its performance, and finally, I'll wrap it up with a summary. Let's dive in. So problems are solved by Rabin-Karp. So what is the problem? Basically, we need a way to quickly find a small patterns that is substrings inside a large text. The naive approach would be the check, would be to check every single letter, which can be super slow for a long text. But Rabin-Karp does something smarter. It uses a rolling hash function to compare numbers instead of characters. This way, we don't have to check every letters unless we are pretty sure we found a match. Coming to next slide, application of Rabin-Karp. Now you might be wondering, where do we actually use this? Well, one big area is plagiarism detection. If you have ever used Turnitin or the other plagiarism checkers, they need to scan massive amount of text for copied content, and Rabin-Karp helps speed up the process. It's also used in institution or detection system where security systems scan logs and network traffic for suspicious patterns. And of course, there's a spam filtering where it helps identify common spam words or parses in emails, in DNA sequencings as well. So coming to next one, a step-by-step operation of Rabin-Karp. Okay, let's break down how this algorithm actually works. First, we compute the hash value for the pattern we are searching for. Then we compute the hash value of the first chunk of uh, text. Then, that's the same size as the pattern. If the hash matches, we do a character by character check to make sure it's not a false match. If they don't match, we slide the window forward by one position and quickly compute the new hash using a rolling hash function. Instead of recalculating from scratch, we keep repeating this until we reach the end of the text. So coming to the example. So example illustration. Let's go through a quick example to make this clear. Imagine our text is some like A B C R A D E, and we are searching for the pattern ABRA. So we compute the hash value of ABRA and store it. We then compute the hash of the first four characters in the text, which also helps to be ABRA since the hash matches. We do a quick character check and confirm it's a match. Then we slide the window over to BRAC, then compute its hash, and then we keep going until we find an AB array at the end of the text. So this is how Rabin-Karp makes such fast and efficient by reducing unnecessary checks. So coming to next one, performance analysis. Now let's talk about performance. So we have different categories in this. Best case, worst case, average case, space complexity. Coming to best case, if the hash function works well and we have few hash collisions, we get O and time, meaning we scan through the text just once super fast. In worst case, if the hash value keeps colliding, we have to check each match character by character, which makes it slow going on to ONM, not ideal. And we have a same average case and space complexity. Coming to comparison with other algorithms. So now, like how does Rabin-Karp compare to other string search algorithms? The naive algorithm is the slowest, checking each position character by character, which takes 0 nm. So coming to rather, we have different things. North Morit pattern, Boyer-Moore, Rabin-Karp is the best when searching for multiple patterns at once, like in plagiarism detection. So coming to the conclusion, so we'll wrap it up things quickly. Rabin-Karp is a hash-based searching algorithm that speeds up pattern matching. It uses plagiarism detection, cybersecurity, DNA sequencing, and spam filtering. It also particularly useful when searching for multiple patterns at once, making it ideal for large-scale text analysis. So while it's not best for every scenario, it's a powerful tool in the right situation. Thank you for this opportunity. Thank you, everyone.